I'm going to talk about very briefly one of our current study on the highest temperature in continental Antarctica. I guess most of you are already aware of what's happening in the Antarctic Peninsula, particularly this year. In July 2017, there occurred a big ice break over the Larsen Sea ice sheet, and when we look at the latest, one of the latest images of the NASA based on the Landsat, we see that there is a clear disintegration of the big ice pack from the Larsen Sea ice sheet. So in recent years, a number of glacial retreats and the ice mass losses have occurred because of the overall warming trend, but also contribution coming from the extreme episodic event. And also in this year, in a very recent study based on the International Evaluation Committee of World Meteorological Organization, they concluded that 17.5 degree made on 24th of March in 2015 on the northern tip of the Antarctic Peninsula was accepted as the highest temperature on the continental Antarctica. So in this study, based on these very recent events, we decided to investigate this all-time record temperature in terms of within the context of the large scale and the local scale change. And finally, we discussed what kinds of trends are particularly taking a role in these kinds of events. So when we look at the events, in terms of the local conditions, this map shows the available stations on 24th of March, and we see that there are extreme temperatures on the leeward side of the peninsula, but also on the windward side of the peninsula, which indicate that there is also another factor that we call the large-scale air advection towards the peninsula. And when we look at the two available snapshots of the MODIS satellite image before the event, before it is the 22nd of March, and the bottom one is the immediately after the event, 25th of March. So we see that there is a clear disintegration of the sea ice, and also some melt ponds over the Larsen Sea and the B ice shelf. So this event is a clear example of the single event can take a big role on the evolution of the sea ice formation, and particularly also a big impact on the formation of the sea ice shelf. We used also another available satellite image of the infrared clouds in order to show the local conditions in detail. So we see that the large-scale advection over here and over the peninsula, we see there is a clear fungi. That means the cloud-free zone because of the dry air occurring on the leeward side of the peninsula. And on that day, the anomaly of occurring in the Esperanza station is 17.3 degree compared to long-term maximum daily temperature time series. So we then look to synoptic conditions. And we see that in the synoptic conditions, there's a surface anticyclonic and a low pressure in different sides of the peninsula, and these synoptic conditions are accompanied with a strong atmospheric river towards the peninsula. And finally, we performed numerical simulation to disentangle the role of the large-scale air advection versus the local-scale topographic induced warming that we call the Fern impact. How we do that? We first use the default topography, and this is the contour simulation. We see the Fern impact warming over the eastern part of the peninsula, and then we did another simulation, but just we removed the surface topography over the northern part of the peninsula, and we see that disappearance of the Fern impact warming more than 10 degrees, and the highest reduction is the 12.5 degrees based on the 3-hour data. So we concluded that a large part of the warming anomaly can be attributed to Fern impact, but the more important thing, large-scale advection of the warming is the main factor that modify and control the occurrence of the extreme temperature event. And we opened the two questions regarding the large-term, long-term change and the recent term change over the peninsula by comparing the two different periods.